Hello, my name's Portia Rooney. I'm the 2025 Auto Skills Australia Churchill Fellowship recipient. My fellowship was on accelerating vehicle-to-grid deployment in Australia by learning from leading global initiatives. I had the pleasure to travel through Europe at the end of 2025 and back home through China in early 2026. So to start with explaining what vehicle-to-grid is, it's basically technology that lets you use your vehicle, your electric vehicle, like a giant home battery, but on wheels. And so you can use this to store energy, say from solar or cheaper energy or renewable energy on the grid, and then use that later back to supply your home, your business building, or sending that back to the grid. So I thought I'd start with a summary for Australian consumers before getting into more detailed technical information. And the key insights from my fellowship was that major EV manufacturers are developing vehicle-to-grid technology. And internationally, we're starting to see the first commercial launch of products, but mostly it's still in the pilot phase. So in terms of this being technology that you can go down to your local vehicle dealership and pick any EV you like to do vehicle-to-grid with, we're still a few years away from this being the case. So in the interim, my strong recommendation is to look for a reputable pilot to join. So you can see a number of energy retailers have started launching vehicle-to-grid pilots, and so you could sign up to one of these. It's really important to start with choosing an electric vehicle that has announced vehicle-to-grid capability in Australia, and then looking at what EV charger that vehicle works with. So at the moment, not every vehicle-to-grid capable charger and every vehicle-to-grid capable EV will work together. So it's really important to find out from the electric vehicle manufacturer to what chargers that car works with. So in starting with Europe, I wanted to share with you a bit more information about Utrecht Energized, and this is turned now into a commercial product in the Netherlands. And so it started with 500 Renault 5s that were car share vehicles supporting the Utrecht energy system, and then now it's being launched also in the residential market. So if you were living in the Netherlands, you could go down to your local Renault dealership, buy a Renault vehicle that's vehicle-to-grid capable, buy a WeDrive solar charger, and sign up to your HEG Energy contract, and voila, you can do vehicle-to-grid. So it's that's quite unique in the world that they've got to the commercial launch stage beyond a pilot. And one of the motivations for doing this Churchill Fellowship is that I've been working with WeDrive Solar for some time now to be their importer and distributor of their charger into Australia and trying to bring this technology to Australia. So here is a nice video that demonstrates what they've been doing in Utrecht.
In a city like Utrecht, energy is everywhere. It comes from its people, their movement, their drive.
A lot of the clean energy we generate is lost.
We often generate more clean energy than we can use during the day. While in the evenings, we need it the most. When the city runs low on renewable energy, 500 Renaults give it back to the power grid. To support 190,000 households, so that the city and its people shine on.
So this didn't just happen overnight. This has actually been over 10 years in the making. And you can see back in 2016 that you had the CEO of WeDrive Solar, Renault, and also even the local grid operator with Bart de Bray sitting there, all signing this agreement to embark on collaborating on vehicle-to-grid technology. I thought it's worth sharing some of the keys to the success of Utrecht and why at this location that they've been able to successfully launch vehicle-to-grid and and commercially now. And so part of that, the keys to the success, I think, are the people and the collaborative nature of the project. So you've had We Drive Solar, Renault, obviously the local grid operator Stedin, Allard, which is a test centre, and the City of Utrecht all coming together to make this a reality. And in fact, the City of Utrecht took it upon themselves, or decided to make their city the world's first bidirectional city. The grid operator played a really important role in terms of this project. They are facing really severe grid congestion, and so they were really incentivised to foster the innovation. And so they actually gave an exemption to the grid codes while this vehicle to grid was still being innovated. And so they said they'd rather have the vehicle to grid technology than apply really strict grid codes in the beginning, and they really supported the development of this technology. So as of this year, they have actually required that the cars and chargers do adhere to the grid codes, and they've successfully done this, but they've also recognised other European grid codes to help facilitate this as well. So because obviously the European countries are connected to the same grid, they've said if you can meet the French grid codes, the German grid codes, or the Belgium grid codes, actually, we are the same grid, and we'll also recognise those grid codes too. Through the Allard, which is sponsored by the various grid operators in the Netherlands, they've provided free testing to EV suppliers and also EVSE suppliers to lower the cost of innovation. The City of Utrecht provided a market for vehicle-to-grid ready chargers in the very early days of vehicle-to-grid, and they did this through providing bonus credits for vehicle-to-grid and through their procurement processes. They also provided reserved car parks for car share through an open market model. This project wouldn't have been possible without We Drive Solar and the CEO, Robin Berg, who's really driven this over 10 years and has installed over 6,000 vehicle-to-grid ready chargers, and 350 of them are currently activated. And so these original 6,000, obviously they've learnt along the way, and some of these are now having their hardware upgraded so that they can achieve vehicle to grid and the grid codes, because actually the charger plays quite an active role in achieving vehicle to grid, even on this AC vehicle to grid ecosystem. So Volvo is another car manufacturer that I met with in Sweden that are working on vehicle to grid, and they're working on both AC and DC solutions. In terms of AC solutions, they're paired with their own branded EVSE, and for DC, they're working with Decibel in the US. And so vehicle to grid doesn't just sort of sit in isolation between the car and the charger. It also needs to be integrated into the home and then back to the grid. And so they're looking at a holistic solution, which includes a home energy management system to manage this, because at the moment, with the lack of interoperability at multiple levels, it really does need sort of a complete holistic solution to enable this technology to seamlessly work for customers. Polestar as well are working on AC and DC solutions. They're working on AC with a company called Zaptec and DC in the US with Decibel. Working with Vernova, they've had a pilot with 30 EVs, and this pilot was about finding the right business models and use cases that can be scaled for vehicle to grid. They've also been working on California's vehicle to grid roadmap. So the big picture in terms of why vehicle to grid is such interesting technology, and it's because vehicle to grid can save the energy system and by default the whole of society quite large figures. So this is the findings of a study from the Fraunhofer ISE, and it found that vehicle to grid can save the EU energy systems $22 billion a year by 2040. And so it does this by reducing the grid battery storage needs, so by up to 92%. It also allows an extra 40% of solar PV capacity into the grid, and then on an individual household level, up to €780 per year of savings on people's electricity bills. So totally, they've calculated that between 2030 and 2040, vehicle to grid could amount to approximately €170.5 billion. So this is almost the entire budget for the EU in 2023. So one of my key observations from my time overseas is considering these, very large $1 billion worth of savings for society. I think we need additional resources to accelerate the rollout. And I say this from having worked on multi-billion-dollar projects and mega projects, and they're really, thousands of people working really hard to bring this value to fruition as fast as possible. And we just don't have these, thousands of people working on this technology at the moment. And some of this is that there's really an investment and reward disconnect. So it's a societal benefit that we can get from lower network fees, from the energy market savings. But in terms of technology development, it's the automakers that are bearing this cost. And it's quite a complex ecosystem that they're needing to launch this technology into. So, for instance, in the EU, there's around 2,500 DSOs, which could all have varying requirements. There's also factors around market drivers for the consumer. So the market can be fragmented and there can be structural barriers present in some markets. For instance, double taxation, where the user gets charged to export energy, though that's now being addressed. And some markets have flat or low tariffs, energy tariffs. So the EU is responding with quite a number of initiatives. You can read this, refer to this list if you like, noting that it's not an exhaustive list. So vehicle to grid does work, but it's not yet interoperable, and interoperability is what we need to scale vehicle to grid. So there's, in terms of the communication standards between the EVSE and the EV, they talk about first and second generation documents. And so the first generation of communication between the car and the charger was called ISO 15118 8-2, but it's not sufficient to support vehicle to grid without the addition of supplementary code. And so the addition of this proprietary custom code means that, and having to develop non-standardized code means that ISO 15118 8-2 is not interoperable. And so we end up with these very closed ecosystems. So the ISO 15118 8-20, which was published in 2022, does support bidirectional power transfer. And so this is the standard that we require for the scaling of vehicle to grid. So what we've seen is that, according to the Vehicle to Grid Hub, that there's now been 157 projects demonstrating that vehicle to grid is possible across 27 countries and involving over 12,000 chargers. Yet we haven't been able to scale this technology because we don't have interoperability. We end up with just a single grid code and a single EVSE supplier and a single EV being able to work and being demonstrated in this pilot. So what we need to do is actually move to the point that we have multiple EVSEs and multiple EV OEMs and multiple grid codes, all being able to support vehicle to grid via this sort of common protocol, ISO 15118 8-20, and we need to get to that point where we can really scale vehicle to grid and move beyond pilots. So the International Energy Agency has established Task 53 on multi-party interoperability of bidirectional charging under the Electric Vehicle Technology Collaboration Program. And this involves 18 countries plus the EU and over 50 industry partners and organisations. It has a focus on DC, AC and wireless charging based on ISO 15118 8-20. And so while ISO 15118 8-20 does support bidirectional charging. It's quite a complex standard, and so there are gaps and bugs in it, still preventing interoperability today. And there's also quite a lot of use cases defined. So unless each party is implementing the sort of same features and has the same common understanding of how, in terms of certain decisions within ISO 15118-20, we end up having to have each party work together still to make the same interpretation. So Task 53 is working on defining a common set of minimum requirements from ISO 15118-20 that all parties can work on, that will support interoperability without having to do these one-on-one sort of relationship sort of testing. And so they're also working on a minimum set of grid codes that are required so that we can achieve this multiple equipment working within multiple grid codes as well. So they're working on a golden guideline that will be published to the public and aiming for Q4 2028 that will define these minimum feature sets to enable others to also achieve interoperability with reference to the golden guidelines. So at the moment, the EU is mandating ISO 15118-20 for EVSEs from January 2027, noting that there's an Amendment 1 of -20 that's due out later this year, and so there may be a delay to that timeline, but we haven't yet heard. Also wanted to share some insights from the workshop sidelines. And so some of the feedback I heard was that new car models will prevent the forced discharge or tricking of EVs using non-approved protocol. And so it'll only be approved protocols going forward that will be able to work with those EVs. I also spoke with the manufacturer of one of the chargers of the importance of having correctly designed and implemented systems, given that we're dealing with high voltage batteries, and I'll discuss that in a little bit more detail in a moment. So in terms of participating countries, Australia's are notably absent from Task 53, although we are acting as an observer through Race for 2030. Because at the moment we're only an observer, we're not really able to participate in the detailed working groups, which is where we need to be to contribute to, say, the definition of the minimum grid codes. Here is a slide showing some of the key parties involved in Task 53, and absent from this slide is actually Toyota, who have just recently joined Task 53, but you can see also there's also Volkswagen, Volvo and the Renault Group, and also Traton, who manufacture heavy vehicles. You can also see from this slide that the lighter sort of vehicles are working on both AC and DC architecture. Traton, who, because they're heavy vehicles, they only charge on DC, so they're the only one that's sort of working on a DC-only ecosystem, and obviously multiple EVSE suppliers from both the AC and DC side. In terms of interoperability testing, that's expected to start later this year and run through 2027, and then the AC vehicle-to-grid testing continue into the early part of 2028, with the golden guidelines expected to be published in Q4 2028. So this is an example of an arc flash that was caused by incorrectly designed charging adapter. And so because we're dealing with relatively high voltage, it is important that we make sure that standards are applied correctly and that any deviation from standards are correctly engineered and reviewed in terms of safety studies. So the key message I wanted to make was that if you're not using a standard or you're implementing a standard in a way that it wasn't designed to be implemented, you are actually undertaking engineering work, and you need to make sure that it's that what you're doing is appropriately reviewed and studied to make sure that your implementation is safe. It's also important to note that Australia's current charging station certification processes contain material gaps in terms of assessing our minimum requirements for communication and integration standards. While I was in Germany, I visited Infineon, who are a really large semiconductor manufacturer, and they produce vehicle-to-grid hardware. And you can see that they're both working on AC and DC hardware, and this is a snapshot from their roadmap. So whether you're doing DC or AC, the powertrain on board does need to be designed to be bidirectionally capable. So for the AC architecture, I thought it's worth noting that the cost of doing this is actually quite low. And so in respect to the inverter, because it's such a low cost to make the inverter bidirectional from a hardware bill of materials point of view, that actually they won't make unidirectional inverters going forward. And what they're happy for me to share with you is that the cost of making that onboard AC powertrain bidirectional is in the couple of euros to the low teen euros. So on a per vehicle basis, it's not a lot of money, although obviously if you're ordering, say, 50 million vehicles, this does still add up. So one could expect that potentially going forward that cars do all have the AC bidirectionally capable hardware in them, and then it's up to us as Australia to make sure that we can utilise this hardware and have pathways to do AC vehicle to grid in Australia supported. As someone who's used to dealing with bidirectional charging as a wall-mounted unit, it was really interesting to see wireless charging. Unfortunately, this isn't bidirectionally capable, but it was such cool technology. It was wonderful to see and experience. And this setup is actually being used for taxi stands, so that when the taxi's waiting for customers, it can be wirelessly charged. So at the moment, this technology is actually economical for heavy vehicles, though for residential vehicles, it doesn't make sense economically at the moment. I also met with Transnet BW, who are a transmission operator in Germany, and the Fraunhofer Institute, as well as Decarbonise, which are a startup in Berlin, who are working on a virtual power network that lets you bring your own energy plan with your EV. I'm working to establish a similar project in Australia, and so this was really interesting to be able to connect with these parties and discuss collaboration with them. So now moving to China. China published the first vehicle-to-grid equipment standard in 2025, and it's applicable to grid-tied electric vehicles. It again supports AC and DC architectures. For AC, this is up to 1,000 volts, and DC 1,500 volts. China's been very strategic in its approach to vehicle-to-grid, and they've conducted over 30 pilots across 9 different cities, exploring different market models, use cases, and for vehicle-to-grid to take those learnings to really come up with a strategic outlook for how to best scale vehicle-to-grid, while recognising that there may be some local nuances required. I visited CATL while in China as well, and had a look through their manufacturing facilities and spoke to their vehicle-to-grid experts. We spoke about a warranty deadlock in that because vehicle-to-grid is still relatively new, we don't have large-scale data to support the full unlocking of battery warranties yet. And this is something that CATL are working on. We also spoke about the potential to develop a strategic pilot program in Australia, utilising our volatile energy market as a high-stress testbed. So my overall impression was that really it's such a small world. The same discussions that we're having in in Australia are the discussions being had in Europe and China, and we also share the same sort of challenges. And so the number one issue that we need to resolve is how do we incentivise car manufacturers? And so what are the market design and reforms that are necessary? And then, of course, there were discussions about what are the pros and cons of AC versus DC, or actually what we're seeing is that both technologies are progressing. So as you see with Task 53 and also China's vehicle to grid standard, but both technology platforms are being progressed. And then finally, how do we unlock the battery warranties? Universally or worldwide, there was also the common recognition of the huge potential of vehicle to grid to support the energy system. So bringing this back to Australia, Australia has really favourable market conditions for vehicle to grid, albeit we're a much smaller market. Because of this, signalling to the market that Australia is open for business isn't actually sufficient. We need to be looking at how do we incentivise the electric vehicle manufacturers that don't have $1 billion carrot dangling there, but which as a society we will, if we can do this quickly enough, get those sort of scale benefits. And we need to be looking at how do we reduce the barriers to their entry. So, for instance, joining Task 53, harmonising internationally where we can in terms of our standards. EVs are such an enormous resource that's co-located with rooftop solar and demand, so we need to be making the most of this opportunity. I really love the analogy between Australia's EV fleet capacity and Snowy Hydro 2.0, and we're expecting by the early 2030s that in aggregate, Australia's EV fleet capacity is actually expected to exceed that of Snowy 2.0. And actually, it's not just Australia that's really captivated by this analogy. It's actually I saw a similar analogy over in Europe, and this is a slide that was prepared by the Mobility House comparing Germany's pumped hydro with electric vehicle capacity. And so this slide is saying that 10 million EVs offer over 100 gigawatts of power and 600 gigawatt hours of decentralised capacity. And this compares to Germany's pumped hydro, which only offers 7 gigawatts and 40 gigawatt hours. So thank you to the Auto Skills Australia, the Churchill Trust, and all those that contributed to this fellowship. It wouldn't have been possible, of course, without this support. These are some of my pictures from my trip, meeting with Renault, Polestar, Volvo, Vehicle to Grid Liberty, We Drive Solar, the Scale final event in Utrecht, Gertsch and Getz from the city of Utrecht, Bart Debray and Allard, Decarbonise, the Task 53 workshop in Switzerland, China's National Advanced Energy Storage Centre, CATL, the Derry Teld Institute, and my hosts in China, Stephen Duckett and Gemma Duckett. Without you, this wouldn't have been possible. So thank you so much to all involved and, of course, the Winston Churchill Memorial Trust.